Good morning to those of you who have joined the webinar so far. We still have just about a minute to go, so we'll give a little more time for people to finish getting logged in, and then we'll begin. Okay, I still see a couple of people who are logging on, but I think we'll go ahead and get started. Good morning, everybody, and thank you for joining us. This is the fifth in the series of webinars that Sustainable CUNY's Smart DG Hub team has been presenting to keep sort of the broader industry stakeholders in the energy storage landscape apprised of the progress on our efforts so far, working with the Fire Department of New York and Department of Buildings to develop procedures for using 9540A, UL 9540A test data in the New York City permitting process. I will do just a quick introduction, a recap of the process that we've gone through. This webinar will cover similar material that those of you who've been on previous webinars have seen, just to provide a recap of where things stand now and what it looks like we will be going next as far as direction. I will then hand it off to Victoria Carey, our technical consultant, and she'll go into the details about where we stand in terms of the specific bucket areas of the explosion, toxicity, thermal runaway, and fire spread topics, as well as key takeaways. My name is Daniela Leifer. I am the project manager of the Smart DG Hub, and I have been managing webinars behind the scenes. Today I'll be taking a little bit more of an active role. And I just want to make sure to remind everybody that to reach our team of DG ombudsmen for any help you may need going through especially permitting related activities or process, please reach out to us at smartdghub@cuny.edu. And as I mentioned previously, Victoria Carey will be presenting the progress today. We also wanted to make sure to bring to everybody's attention again, the FDA released a proposed rule several weeks ago. This would cover permitting requirements for outdoor stationary storage battery systems. You can view the current draft of the rule as well as comments that have been submitted so far. The close of comments was, I believe, May 31st. New comments are not being accepted as of right now, but are being reviewed internally at FDNY And we definitely encourage those in the industry to keep up to date on the process of this rule development. And just a minute of background about the Smart DG Hub for those of you who are joining for the first time. The Smart DG Hub, a project of Sustainable CUNY, is a neutral third-party platform. We bring stakeholders together from the various players sort of in the larger renewable energy field and our current project focuses, of course, on energy storage permitting. We work with everybody who should have a seat at the table and a say in processes for permitting and sort of regulatory development on the city level. Just about a year ago, this project platform developed the first lithium-ion permitting process guide for New York City. Again, those of you who are unfamiliar, please feel free to reach out for more information about this if this is not familiar to you. And a brief bit of background about permitting considerations for the City of New York. There are several departments involved in the overall process. Developers that are looking to site a project in the city need to work with both the Fire Department of New York for technical review of your project plans, as well as the Department of Buildings Office of Technical Certification and Research. The office focuses on technologies that are fairly new to the city and may not have established permitting pathways. In addition, you do have to go through the standard sort of more established permitting requirements with the Department of Buildings, including construction and electrical permit applications. The overall design and safety considerations that go into review of an energy storage project include lifecycle management, while the maintenance for the project while it's in service, as well as decommissioning afterwards. Status communications on the essentially health of your energy storage system and how it's functioning. Signage directed at first responders. Cascading protections around preventing thermal runaway or abnormal events from propagating to nearby adjacent equipment or cells, as well as ventilation, exhaust, and fire protection and siting considerations. The bottom 4 categories are those that are covered or informed by the UL 9540A large-scale burn testing. And this large-scale testing, following the UL 9540A methodology, is currently required for all energy storage projects submitted in New York City. And the 9540A process is what must be followed for large-scale burn testing. The data is used to evaluate the fire characteristics of an energy storage system that has gone into thermal runaway. The point of the test is to drive a system into thermal runaway, not to see whether it will or not. It's not a pass-fail test, but the point of the test is to collect data and see what that data tells you about how the system performs, specifically in a fire situation or a thermal runaway situation. And as of right now, the test is not designed to, again, sort of provide like a pass-fail criteria. And of course, the data that's generated is used to determine certain siting and siting, fire protection, and other requirements for individual energy storage projects that are looking to go into New York City. The goal of the project here ultimately is to develop a guide that will provide a sort of a systematic way for both developers as well as the reviewing agencies to analyze and apply this data. FDNY and DOB have been contributing their current process for how the projects that are coming in are being reviewed. currently. We are working with a pretty wide team of subject matter experts in various fields, including fire protection engineering, explosion analysis, et cetera, just to provide their input, guidance, and their knowledge about about energy storage systems to the AHJs. And CUNY is acting as the facilitator to document this information, collate it, and ultimately draft up a final deliverable that will be used. We are likely going to plan a sixth and final webinar that will provide a summary of not only the information that's been coming out of the weekly meetings that we've been holding with the agencies and the subject matter experts, but again, to provide the broader industry information on the deliverable status of the data analysis guide itself. So we will send out announcements about that once sort of plans have been a little bit more solidified, as well as a date for this webinar. So please stay tuned. I will now hand it off to Victoria to go into the nitty-gritty.
Thanks, Danielle. So this is for those of you who have been on these before, as Danielle mentioned, this is intended to be a recap. So there's not going to be a ton of new information in this that hasn't been spoken to before. But if you're new to these meetings, welcome and thanks for joining. So these 5 topic areas are the areas that we've been talking about for the last several weeks and sessions. As Daniela noted at the sort of top of the presentation, we have gone through thermal runaway, fire spread, explosion, and toxicity during our discussion sessions. Yesterday we had a great and productive continuation of that conversation where there were some open items from each of those topic areas that we were revisiting and trying to get to a more conclusive place on as possible. Essentially, in essence, through that process, we've been working through performance-based design. So as we've been moving forward, we've readjusted our thoughts around the performance-based design, and they've kind of gotten slotted into these other topic areas. So we've been addressing it as we've gone along. And as I noted, we're still working through a few open items, most of which are related to performance-based design. So that's a bit of an ongoing conversation, but we're moving right along and getting through these items. You can go to the next slide. So if you're new to these meetings, this might be the first time you're seeing some of these flowcharts. Essentially, these flowcharts are intended to address the gap between the end of the UL 9548 testing procedure to the submission of documents acceptable to the HJs, as well as support for designing your system in accordance with the information you've now gathered from the UL 9548 test. So these flowcharts first help walk through what some of the decision points would be for continuing on in the testing, and then second help to walk through some of the calculations and analysis that go on after the testing is completed. However, even from those, there are still some points of clarification, which is why we've been hosting these meetings in order to make sure that the process is as transparent and as explicit as possible to both allow for folks to come up with creative designs, but also to give some guide rails to get to a point where the information you provide to the HJs will be understood to be appropriate or in line with their expectations. So we've been using these flowcharts as the baseline for each of our conversation areas as they relate to thermal runaway, fire, spread, explosion, and toxicity. You can go to the next slide, Danielle. So the first topic that we decided to handle was around explosion. So the recap here is, first of all, I think a critical point on the data sources. So UL 9540A is required for all installations. There's not a differentiation between chemistries nor between system sizes. There is some progress and updates being made for the 4th edition of UL 9540A, which you can read in some of the memos that they've released on the UL website about some of the changes that are coming between the 3rd edition and the 4th edition, and that will help to address some of the different chemistries as well as some of the different size considerations. For the test levels, if you're not directly familiar with the test layout, it starts at a cell level, then goes to a module level, then goes to a unit level, which is typically interpreted as a rack, and then goes to an installation level, which is identical to the unit level but inclusive of non-water-based suppression or water-based suppression techniques. If you are doing an explosion analysis based off of the UL 9548 testing data, the required process is to use the cell level test to figure out what the composition of the gas will be, as well as some of the other characteristics of the gas, such as the fundamental burning velocity and the LFL. And then you use the unit level test. As I said, it's sort of the rack level test, which will dictate the volume of flammable gases released and the flow rate of those flammable gases. For the data sources, there typically in New York City is a list of laboratories that are approved for various tests that are certified to perform those tests. Because of the current status of UL 9540A, that's not really available at this juncture. However, what has been stated thus far is that test data from UL or from other nationally recognized testing laboratories, especially those that are certified to perform UL 1973, would be considered. Data from those would be considered as long as they were performed in line with the methodology which was outlined and have the appropriate capabilities to meet all of the requirements outlined in UL 9548 test method. There was also a discussion around having to repeat tests for multiple types of systems, and so there was a discussion around the variability in system design that the test lab that performs the test is allowed to assess a variety of modules or rack configurations, ascertain which is the most worst case scenario, and then test on that. There does need to be a basis and decision-making reasoning that's provided along with the reason that this test, even if it is not identical to the system being installed, is appropriate. A quick example that I think would be quite easy to provide reasoning on would be that you have two different rack sizes, one that has 15 modules in it and one that has 20 modules in it. And so through this worst case scenario discussion, potentially you would want to test the 20 module rack rather than the 15, because you would see it as a worst case scenario because there's more material that could be engaged in the fire, as an example. But the test lab should go through a quantitative analysis and determine which is the worst case scenario, if that is to be accepted by the HJs. Assumptions and calculations that are included here in the explosion analysis. One note was that the definition of the container volume, which is really important for figuring out what the explosion would look like if it occurred. You take the total volume of the space, so if it's an outdoor container, you take that container volume, and then you can subtract the obstructions. And so obstructions would be the racks themselves, any telco racking, anything that's in the container that's taking up room, you would subtract their volume. There's not a need to consider, minor void spaces maybe that exist within the modules or between the modules. You can look at them as a solid block. For figuring out what values are tested versus calculated, the lower flammability limit would be a tested value. There's a standard that's cited within UL 9540A that is the appropriate methodology to use to ascertain the LFL, and that should be included in the UL 9540A test report that you receive from the laboratory. But a value that's calculated is ventilation impact. During the testing conditions, there's There's ventilation that would be running or exhausting that would be running in order to pull the gases and analyze them or to ensure the safety of the laboratory. And that ventilation may not match the ventilation that you would see in your actual installation, but you're permitted to use a calculation to figure out what your ventilation would be. So you don't have to run a test with your ventilation. And then finally, there's been some questions around, if you can remain below 25% LFL, that this is sort of a procedure to prevent explosion. However, even if you can demonstrate through a calculation of ventilation that you remain below 25% LFL, you still need to do a calculation determining what the partial volume deflagration impact would be, and then appropriately mitigate for that sort of reduced pressure situation. Regarding acceptable threat mitigation strategies, NFPA 68, and it's not cited here, but 69 are both acceptable. In addition to that, FDNY and Department of Buildings have noted that they would review other similarly validated models, given that appropriate documentation is provided and that they're signed off on by a registered professional engineer in the state of New York. In all cases, upward deflagration is required. If there's a desire to have a deflagration panel pointed in a different direction, these would be reviewed on a case-by-case basis, but strictly speaking, upward deflagration is really the only acceptable mitigation measure at this juncture. When considering what threats need to be addressed, fireballs and pressure waves are both a little bit more obvious. Projectiles are also important to consider. All of these are covered in NFPA 68. The ongoing discussion is around threshold. So what is the acceptable threshold of risk for distances to egress pathways, distances to fire department connections, and distances to buildings. So we've got some input on potentially acceptable calculation methods for this, and sort of determination of these, and that's something we're still working through finalizing. You can go to the next slide. The recap around toxicity discussions is a little bit of a shorter slide here. Essentially, for the impact that toxicity would have on first responders, it's understood that the PPE or personal protective equipment that first responders wear should be sufficient to protect them from any toxic gases coming off of a battery fire. There's also plans in place within FDNY already for approaching these types of events with defensive tactics. So reducing the likelihood of injury to first responders there, rather than having any particular requirements for battery manufacturers or developers. For bystander impact, there are some references that we've been pulling, both within the fuel gas code as well as in the electrical code, on the requirements for any secondary means of egress from spaces that have energy storage systems. And so we're pulling and assessing those references. And similarly, we are looking back to electrical and fuel gas code for exhaust locations where they would be appropriate distances from various exposures, windows, doors, openings, walkways. And then finally here, the idea around toxicity, it's not directly actually addressed in the UL 9540A testing methodology. It's not included in the decision tree that we showed at the beginning. However, the data from UL 9540A can, it determines what the speciation of gases are that are released from a failure event. And so it can be used to sort of qualitatively compare to other fires, more common fires. And if the profiles are found to be similar, there's not an expectation that there would be any additional burden placed on these systems in regards to their toxicity. You can go to the next slide. On thermal runaway, I think the most critical thing here to understand is that 9540A, as I mentioned earlier, is always required to determine if a system goes into thermal runaway. The testing methodology is quite clear in that the first required way to initiate thermal runaway is through the application of heat. There are other subsequent ways to attempt that thermal runaway if the initial application of heat is unsuccessful. And it's understood that there are some systems that have gone to a great deal of effort to reduce the possibility of thermal runaway. However, the purpose of UL 9540A is to initiate that thermal runaway. So while the reduction of possibility is appreciated and important, especially when we're starting to look forward into the future for indoor installations or installations near sensitive locations, it's definitely a critical piece of a risk analysis, but that reduction in likelihood does not absolve you from having to complete the test. So UL 9540A will be required in all cases. And if the claim is that thermal runaway cannot be initiated, then that will be demonstrated through the first level of testing. Just as a prescriptive measure, this is specified in the New York City rule. It's been specified in the DOB memos, and it's been specified in the guidelines that Daniela mentioned up front. But BMS controls and system monitoring are required 24/7 to determine, the status of the system, and so that's just a prescriptive requirement. And then thermal runaway, we did try and separate it out from the other system assessments, so fire, spread, toxicity, and explosion. So the consequences of thermal runaway, be it fire, spread, toxicity, or explosion, are addressed in the other three topic areas. So in all cases, those mitigation measures need to account for that worst case scenario that's determined by UL 9540A, but the thermal runaway is that first step to determine if it goes into thermal runaway. You can go to the next slide. And then finally here, this is the topic area that we're going to go into a little bit more detail here because we did have a bit more of an extended discussion. This was one of the ones that had the most open items in it, as it was the last topic area that we covered. So for our purposes, we're defining fire spread essentially as anything past thermal runaway. So it's gone from a single cell. It's now starting to cascade to cells around it. A single cell or however many cells is required to initiate based on the testing design. It starts to cascade. It's engaging the rest of the module. It's engaging neighboring modules, plastics, adjacent walls or containers. So that's the fire spread overview. And I think you can click twice through here, Daniela. There you go. Just one more time. So there was a bunch of test data there. I didn't want to go into that in too much detail. But sort of the critical things that FDNY and DOB are looking for when they're considering the risk of fire spread, both as a risk to property and a risk to human life for occupants and for first responders, are these sort of 7 key areas. So undetected failure, and can you just click once for me, Danielle? So undetected failure is this first topic that they want to address, and this is being addressed primarily on the thermal runaway side of things, and is addressed more prescriptively to make sure that there's the appropriate sensors, to make sure that there's appropriate monitoring, and that there's some triggering of a response once a failure is detected. So this is a little bit of a redundancy thing, a planning in basic design, and addressed through some of the prescriptive measures. The next item of concern is reaching LFL. So you can go to the next slide. And this is proposed to be addressed through ventilation strategies. It's recognized that the LFL may be reached regardless. We've already discussed how explosivity is managed, and so if it can't be handled through ventilation, then it would be handled through some explosion mitigation strategies. You can go to the next slide. The safety of occupants is addressed here through ensuring that whatever the measured impact of the fire that's recorded during the UL 9540A testing, that piece of information helps to determine how far away egress routes need to be, as well as what are the appropriate passive protections that are included there. So if there's an additional fire-rated barrier that's required and a certain amount of spacing that's required from an energy storage system to an egress pathway, that's the information that's going to be lifted from UL 9540A. Alarms here are also identified as something that can keep occupants safe, but this is a prescriptive measure. The requirement for alarms is universal. You can go to the next one. For the safety of first responders, again, getting data from UL 9540A, you can pull what the temperature is at various distances, and with that determination, you can determine what the impact would be on a human body. And so from that, you can determine both how close the fire department connection could be while still maintaining first responder safety, and second, ascertain the appropriateness and effectiveness of PPE that's being utilized. As an internal point, as I noted previously, FDNY is developing procedures, SOP, standard operating procedures, to ensure that first responders are kept safe. So that's more of a generic thing. There's not a requirement for applicants to provide that, but the test data in aggregate, seeing it from multiple installations, is helping to develop that procedure. You can go to the next slide. The destruction of property is another concern or hazard that is looking to be addressed. The key part that's applicable to the UL 9540A test data utilization guide would be the observation within the UL 9540A test, both during the unit level test and the installation level test, of what property is impacted during those tests, and if the mitigation systems in place are effective at preventing further fire spread. And for the next one, the unknown effectiveness of protection and suppression measures. So the installation level test will demonstrate that directly, and it's understood for outdoor systems that a dry pipe system is being required in those cases. And in that case, there's a prescriptive requirement around that of 0.5 GPM, which is sort of the highest in code for sprinkler design for a high hazard area. And so the installation level test is testing the automatic suppression measures such as a clean agent release, Novec or FM200 or similar, or other agent releases and inerting agents, as well as the inclusion of any sprinkler system that's triggered automatically and sized based on performance. And then finally here, with the threats of incomplete combustion, if you go to the next slide. Could you go to the next slide? I don't know. Second. There you go. So the threats of incomplete combustion are understood to include, ensuring that there's a proper decommissioning process in place, so that if you have a module that's only half burned up, how do you remove that from the site? So that's handled prescriptively, and there's a requirement to submit a decommissioning process when the application is submitted prior to installation. In addition to that, incomplete combustion is understood to also potentially pose an explosion risk, and that's addressed in the explosion risk section. So we won't go into that in further detail here. Go to the next slide. So these are some of the sort of the key takeaways on fire spread. The flammability of gases is determined through this ASTM testing methodology. This is cited within UL 9540A. We've gone through a few definitions here. Containment would be defined as heat not able to escape the target unit. So there may be something within the unit which is past the point of of thermal runaway, but that as long as that heat doesn't escape that target unit, that it would be considered to be contained. And so that's a useful determinant in deciding if you need to move forward between the module and the unit level test, as well as the unit and the installation level test. Effective suppression is defined as full extinguishment, so no further fires are coming out of the container or rack or module, both initially after the initial hit of whatever the suppression agent is or water is, as well as down the road that there's no reignition. Water-based suppression systems are recommended to be designed to NFPA 15. It's recognized that some of the dry pipe systems that are being permitted for outdoor installations currently may not be fully aligned with that, and there's an allowance for this tie-in by the first responders into a dry pipe system, and that's recognized as permitted. There's a note here in the flowcharts around a term, fire propagation hazard is not demonstrated by tests. And so that's defined as there's no flaming outside of the room. There's no flame propagation to the overhead cabling, which is sort of a example of what could occur if there's any flammable equipment overhead or nearby. The target unit temperature is lower than the temperature with which cells vent. There is currently a consideration for the fourth edition of UL 9540A to allow the temperature sensors to be installed inside of the target unit to get sort of a more accurate read on if there's any protection equipment that's on the outside of the racks. And the temperature rating of the wall is less than 97 C plus the ambient temperature. That temperature rating is applicable for combustible materials. We initiated a conversation about how fire-resistant or non-combustible materials are assessed. These are currently sort of assessed separately, with the understanding that if combustible materials are nearby, you want to understand how they're going to react. But this is an ongoing conversation as to how do you determine if you need a 1-hour fire-rated wall versus a 2-hour fire-rated wall. And so that's an ongoing conversation. You can go to the next slide. As you see here, the sort of the blue items are these kind of ongoing conversations, which we've continued with in this last week. You can go to the next slide. Continuing through some of the analysis requirements that we've discussed thus far, the unit spacing determination. So spacing between energy storage system units is only determinable through the UL 9540A testing directly. So although there's theoretical methodologies of how you could determine what the spacing could be based on the data that you gather. Right now, if you take a unit or a rack, you space it 3 feet away from the next adjacent rack, and you demonstrate that at that distance, the adjacent target unit does not rise above the temperature at which cells vent, then you're good. Moving that unit closer would require, at this juncture, a retest. Moving it further away would be acceptable and would not require a retest. There is an ongoing discussion about if there are theoretical methodologies that would allow for you to conduct the test once and then using that data, move that system around without having to retest. And part of that hinges on the inclusion of a measurement of heat flux, which is under consideration for inclusion in the test methodology. However, although that cannot be determined, spacing between units cannot be determined through modeling or calculation. Once you take the temperature readings at adjacent walls or egress routes or other distances that are not the racks themselves, those spacings can be adjusted based on calculation from the UL 9540A data. So, for example, if in your test you have the system 3 feet away from a wall, and you determine that there's not a threat from that placement, you can do a calculation using the data collected from that placement to determine how much closer you can get the unit to the wall before it becomes an issue. As I mentioned earlier, and as is universally required, all designs have to be stamped by a New York State PE, and regardless of whatever the methodology is used, that needs to be documented and provided along with the application. It is appreciated that there's some SOP development that is currently underway, and so that's understood to be in process. There is still a definition needed, and can you click to the next slide, Danielle? I'm just figuring out if this goes blue. Yes, there is still a definition that we're working through on the appropriate level of mitigation for residential units. The Department of Buildings has previously released and is continuing to accept applications for residential units based on prescriptive requirements. Those prescriptive requirements are outlined in the lithium-ion outdoor guide. So this is for the outdoor installation of residential units. And it essentially, in brief, includes a fire-rated, 2-hour fire-rated wall behind the unit that extends 5 feet in all directions and 10 feet in the direction of potential flame travel. So that prescriptive application is still accepted by the Department of Buildings, with UL 9540A as an option in order to move forward with installations that differ from that prescriptive requirement. You can go ahead to the next slide. So essentially, what we're doing now is we're just we've consolidated all of our meeting notes. We're trying to organize them into sort of key takeaways, as we've been doing within these meetings, these stakeholder calls. So we've consolidated all of these meeting notes. We're separating them out into the key takeaways, and then we're figuring out if there are any remaining gaps, and rolling up our sleeves and really trying to get through those remaining gaps and get as close to an answer as we can. We've noted here that we're moving on to performance-based design, but really what we're just doing is moving through those open items, which chiefly are around performance-based design, but we're not having a separate series of discussions about performance-based design as it is. We always welcome additional case studies. So if you have some information that you would like to share with us, we welcome that at the DG Hub address. We look forward to your input and feedback on that. I have to apologize. I wasn't touching my laptop for a while, and my screen went dark, so I can't see the presentation anymore. But I do think that gets us to the end of our slides here, Daniela. Essentially, what we're planning to do moving forward in brief is close out the open items. We'll be working through the exact format that is most useful to the HJs to digest this information. And then once we get to that point, once we get to some definitive conclusions, we will get that into a document that's acceptable to all parties to make sure that there's transparency in this process for the stakeholders, you guys who have been on these calls and listening in. We're working through sort of that formatting and discussion around that deliverable in the next few weeks as we battle a few vacation schedules. But we're working to get that out definitely as soon as possible once agreement of all parties is reached. So looking for that a little bit later this summer. And we are working to schedule another one of these stakeholder meetings when we are ready to release that information. And Daniela, I'm not sure if you could speak a little bit to the way that we'll reach out to folks. I think anybody who's been on these calls and we have on the email list will receive an email letting them know about the date as you've had for the last few meetings. Is that correct, Daniela? Right.
We'll use a few different announcement vehicles. We have the list that was used for announcing this 5 webinar series, and we also maintain a few roundtable Google group lists. So yeah, we'll make sure to get it out there far and wide.
Great. So that's all from me today. I think that we typically open here for any questions.
Right. We did have just a couple of questions that came in. So as with previous webinars, I'll hand that off to Ron.
Thank you, Daniela. We have about 15 minutes left for questions. As Daniela said, there were a couple that came in during the course of this webinar, but this would be a good time for everyone, if you do have a question, to enter it into the question box so we can get to it during the time that's left for this session. So looking at what has been submitted so far, someone asks about the new draft FDNY rules, which don't require 9540A for small and medium-sized systems, and wonders whether this distinction will remain for small and medium-sized systems in the final rules.
Yeah, this is Derek Meister from the CUNY team. I can take a shot at this one. So granted, we don't know the timing of when the final rules will be put in place. And of course, there are open comments that are being reviewed by the FDNY team. And there will be changes potentially. We also don't know what those will look like. And then of course, there are overall kind of implementation processes that will need to be put in place as well. So a few things are definitely unknown at this point, but overall, the biggest thing to point out within the draft rules is that test data is still required for what they're calling an equipment approval process. So essentially, a product that comes into the city will need to go through this equipment approval process with the acceptable data, generally from 9540A, and from there be able to go through permitting within the city without having to submit that data every time. There is a kind of sub-note caveat where if there is kind of a listing for the system as a whole, that is not required, and that kind of system can go into the city without that equipment approval process at large. So, of course, currently the process that we've been outlining requires the review with FDNY and DOB's OTCR office, and that data, 9540A test data, does still have to be submitted, but to be seen how that's going to play out once the final rules are in place. But it is likely, from my understanding, that this equipment approval process will be required and will require test data, although within the draft rule, they do mention other acceptable data, other acceptable and approved data. So potentially for other chemistries than lithium ion, if other testing has been done through other methodologies and certifications, then reaching out to FDNY and the DOB teams early on to see if it's acceptable will be important.
All right, thanks, Derek. We have a follow-up question regarding the FDNY rules, and one of our participants wants to know how IFC 2021 is going to impact those rules. Maybe we should start off by just a quick explanation of what IFC 2021 is.
Yeah, well, so that's a part of the international code rulemaking processes. I'll just mention up front that the city does not quite follow at least the rest of state in terms of the building and construction codes. The city does have its own NYC specific code requirements, and those code cycles are a little bit behind the current ICC committee cycles, and even the states actually. So overall, the construction codes within the city aren't moving to 2021 anytime soon. I believe they're still based off of 2012, and the next iteration for the overall code cycle within the city will likely be around 2015 or 2018 codes. But that being said, I think, Victoria, if you have any more insight into how these IFC 2021 rules will be utilized by the city, think that'd be helpful.
No, I think that was a good summary. The one thing I wanted to mention was that I know that the draft 2021 IFC was considered in the New York State model code that's been, or model law that was published, and the guidelines that were related to it. And so, I think it's definitely a good thing to take a look at. But I think as folks are aware, code revision cycles come every few years, and so formally, the rule as it stands would be what the rule is, and if they're trying to integrate anything into that, there would have to be some modification done formally.
Right, and in terms of the draft rule right now, a lot of the content within was pulled from various kind of code cycles and committees that are ongoing. So a lot of the information is relevant to these latest codes that are coming. And of course, they have left room within the draft rule, at least, for making updates and changes periodically as obviously more data comes out and more information around standards comes to light. But of course, that's also a part of kind of a committee process, and changes probably won't happen immediately and all the time. So just look out for any updates in the future.
All right, thanks. We have a question that's come in about thermal runaway, and one of our participants asks if there's a reason that thermal runaway is used as the primary fire initiation source for large-scale fire testing.
I'm not sure I can answer the reason that UL selected, and I think maybe the intention was to specify the application of heat as the primary method. I think the critical point is that there are other test methodologies that determine the resiliency of a system to a variety of abuse conditions, and the point of UL 9540A is to determine what happens if a failure occurs. And it's less about how does the failure occur, and it's more about understanding that if a failure occurs from any angle, what is the resultant off-gassing or abnormal failure event that occurs from there. So I can't speak to the reason it was selected. I would imagine because it's probably the most consistent way to ensure that a failure event occurs. But that I'd have to direct over to UL if there's an additional thought process behind that. But just, again, to reiterate that UL 9540A is designed to capture data after a failure event occurs, and other tests can determine sort of the ability to avoid that failure generally.
Thanks, Victoria. Another question came in. This goes back to the comments that Derek had made earlier about codes, and someone would like us to reiterate what codes are applicable for systems going in this year.
Well, just to be clear, I was kind of talking about the construction code cycle within the city at large. So that's building code, fire code overall. And again, my understanding is that the committees for looking at those codes are primarily looking at the 2015 ICC. Those committees have been ongoing for years, and no idea when kind of the overall building code cycle will change. But that being said, because it is going to be based off of a code, an international code that doesn't necessarily address specifics for energy storage systems, there still will be room for the agencies to adopt kind of similar to the draft rule methodology, where it'll be kind of a more specific and tailored requirement section for these systems. So using it from basically, obviously, bodies are able to adopt amendments to these international codes that are more strict, and that would have to be included on that end for energy storage systems within the city. And of course, that's that's a part of the reason why currently the process for reviewing these systems is so hands-on with FDNY and DOB because there are no current codes. But looking towards the future, it will be this draft rule from FDNY for the time being.
Thanks, Derek. Going back to the answer that Victoria gave a few minutes ago about thermal runaway, I've heard now from Jim Trudeau from UL, who's on this call, and he says that Victoria was correct in her comments about heat being used to force thermal runaway. So there's validation for you, Victoria. Excellent. One other question that's come in, someone would like to know if we can explain how the UL 9548 test data will be presented to various audiences, whether it's fire chiefs, the general public, or other stakeholders.
I can't necessarily speak to that. That would be I think along something that the HJs would have to weigh in on to a certain extent. But from our current understanding, someone who's applying would have to do the analysis. So these different analyses methodologies that we walked through around explosion, fire spread, and in some cases toxicity. Some of these indoor systems that we're looking at. And then in addition to that, as an appendix, you have to provide just the full test report along with that application. This would go internally to the HJs for their consideration. Further release of that, I don't believe would be necessary. But again, that sort of depends on finalizing the process that the HJs are using, which is part of the intention of this process to make that more transparent.
Thanks, Victoria. So we've come to the end of the questions that have been submitted, which is good because we've also come just about to the end of our allotted time. So I'm going to turn it back to Daniela now. If there are other questions that people have and weren't able to submit during the course of this webinar, they can always send them in to us at our email address, smartdghub@cuny.edu. So Daniela, I'll turn it back to you to wrap things up.
Thanks, Ron. Basically, that's what I was going to say. If anybody has remaining questions, please reach out to us at SmartDGHub. And that is pretty much our wrap. Thank you all very much for participating in this one and any of the previous 4 webinars. And please keep an eye out for announcements for our final sort of summary later on this summer. Thanks so much.